In this video, you will learn about several advanced features of Intact.Design, including how to apply multiple materials and change simulation settings, apply restraints, apply advanced loads, and analyze results. The model used in this video can be downloaded from GrabCAD. For a detailed explanation of how to import this model to Intact, watch the tutorial video Importing SOLIDWORKS Assemblies. As with setting up any scenario, the first step is to apply materials and change simulation settings. Open your model and then click New Simulation. Let's begin by changing some simulation settings.
Since the shovel is an assembly, the Set Multiple Materials option is available. Hover over the part description to highlight it in the viewport. Let's set the handle and shaft to be fiberglass, a common material used on shovels. In the Material pull-down menu, it is listed under Engineering Plastics as acrylic glass fiber reinforced. Finally, let's set the head of the shovel to be steel AISI 304. For a list of material properties, see the Intact.Design documentation.
Click Save Materials to return to the main window.
Use the resolution slider to increase or decrease the number of integration elements. Check Show Basis Functions to display the grid on the model. In general, you want there to be at least a few grid cubes across every cross-section. The lowest possible resolution is not sufficient for this model. The highest resolution would produce the best solution but increases computation time. Select a resolution somewhere in the middle, around 100,000. Next, set the up direction. Since we want the shovel to be stuck in the ground and vertical, +Z is the up direction. Next, set the unit system for forces. Let's use inch, pound, second.
The next step is to apply restraints. Click the Advanced button to go to the Advanced Scenario window, then click Add Restraints. To add a restraint to a small area, you might want to check Select one face at a time. To quickly select multiple faces, use the Paint tool by holding Shift and dragging your mouse across the model. Since we want to restrain the entire head of the shovel, as if it is stuck in the ground, it is easier to deselect the checkbox to select larger faces.
Once you have selected all the faces you wish to be restrained, click the Restrain Selected Faces button.
Once you have added restraints, the next step is to add loads. Click the Add Loads button. There are 4 different load types to choose from: vector, pressure, torque, and gravity. First, we'll add a vector force to simulate someone pushing on the handle to force the shovel into the ground. As with selecting faces to restrain, you can check the box to select small faces or hold Shift to select multiple faces at a time. Select the top face of the shovel. Use the force magnitude slider to apply a 50-pound load to the selected face. To get an exact value, it is sometimes easier to use the up-down arrows or manually type in the value. Use the bottom 2 sliders to adjust the direction of the force. The polar angle is measured from the z-axis in the xz plane. A polar angle of 0 degrees is aligned along the z-axis, an angle of 90 is along the x-axis, and 180 is aligned along the negative z-axis. If we set the polar angle to 90, we can see how the azimuthal angle moves. The azimuthal angle is measured from the x-axis in the xy plane. An angle of 0 degrees is aligned along the x-axis. 90 degrees would be aligned along the y-axis, and so on. For this scenario, we want the polar angle to be 180 degrees and the azimuthal angle to be 0 degrees. These settings apply a 50-pound force in the negative z direction. Once you've applied the load, the vector will be displayed on the model. Look at the arrows to ensure the force was applied correctly.
Next, let's add a torque to simulate someone twisting the shovel. Change the torque magnitude to 25 inch-pounds. Again, use the up-down arrows or type it in manually to get the exact value. The remaining sliders are for specifying the torque axis. Use the polar and azimuthal angle sliders to change the orientation of the torque axis. Refer to the model in the coordinate system to visualize changes. For this scenario, both angles should be set to 0. Use the X, Y, and Z sliders to change the location of the torque axis. For this scenario, set the X and Y values to be 0 so that the torque axis is aligned with the central axis of the shovel. It might be helpful to move the Z slider so you can see the axis above the shovel. Don't forget to select the surface, then hit Done. Look at the arrows on the model to verify that the loads are applied correctly. Lastly, add the force due to gravity. Check over all the loads you've applied and click Simulate. You can track the status of your simulation in the Simulation Inventory window.
Once the simulation has run, the last step is to analyze the results.
Click on your simulation to view results once it has completed. Use the Deform slider to visualize the exaggerated displacement. Notice that the shovel deforms in a way you'd expect given the loading.
The max displacement value can be found on the right side of the color scale. You can also shift-click on the model to display displacement and stress values at a particular point. Next, let's take a look at von Mises stress. You can adjust the maximum value on the color scale slider to decrease the threshold stress value to display as red. You can see that the areas of highest stress are along the shaft and where it is connected to the handle and head. Next, let's review the scenario details. You can review the material you selected for each part and the loads you applied. Click the bottom checkbox to display loads and restraints on the model. The restrained surfaces are shaded black and the loads are shown with arrows. You can share your results by copying the shareable link or downloading a GIF.
Thanks for watching. If you have any questions or comments, please visit Intact.Design.